Welcome back. Now we are going to discuss the chapter motion in a plane. In the previous chapter, you discussed or you understood motion in a straight line. Motion in a straight line is motion along one axis, that is motion in one dimension. So in that chapter, the body was moving only along x-axis or only along y-axis or only along z-axis. It was that kind of a motion. X-axis or y-axis or z-axis. Any one axis. The body was moving only along any one axis. Hence, to describe the motion of the body, we required only one coordinate. If it is moving along x-axis, we needed the x coordinate. If you knew x is 1, x is 2, x is 3, x is 4 like this, we knew where the body was. If it was moving along the y-axis, we required only the y coordinate. If we knew the y coordinate, we knew where the body is. Similarly, if the body is moving only along the z-axis, we need only the z coordinate. We will know where the body is. Therefore, in motion in one dimension, if it is moving along x-axis, the values of y and z was 0. They were 0. It was moving only along x-axis. See, no up, no forward, coming out of the board, no going into the board. Going right and left. That's how it goes. Similarly, if it's moving along y-axis, it is either going up or coming down. Z-axis, coming out, going in. It was like this. But in motion in a plane, the body is moving in two axes, which means the coordinates in both the axes are changing. Here we have three axes, x, y, and z. But in the plane, only two axes, x and y, or y and z, or z and x. Any two. When the body is moving, the coordinates along x-axis and y-axis will change. So initially, if the body is here, then we describe it with coordinates x and y. If y is also 1, 1, 1. Let's say the body moves somewhere else, 3, 4, like this. So we need both the coordinates, x coordinate and y coordinate, to describe the motion of the body. If we can do that, then that is motion in a plane. Now this is a little different from motion in a straight line. In motion in a straight line, it was a very simple concept where you said if a body is going in a straight line, you would have learnt it as left, right. Either the body can move left or right. Similarly, the body can move up and down. It can move up and down, or it can come in or go out. But it cannot move left, right, and up and down. Not possible. That would not have happened in motion in a straight line. Either moves forward, backward, or up and down. But it cannot do forward, backward, and up and down. That facility is not available in motion in a straight line. But motion in a plane, the body can do that. The body can move forward, backward, and up and down. See, for example, a motion like this. So if this is a pen, if I apply a force on the pen upwards, the pen will move upwards. Same force if I apply along the horizontal, the pen will move along the horizontal. But what if I apply a force like this at an angle? Then the pen has gone up and the pen has gone along the horizontal, which means there's a motion or there's an effect of force along the vertical and there's an effect of force along the horizontal. So in this case, the body is moving both along the horizontal and along the vertical. If this happens, this is motion in two dimensions. So the examples for motion in a straight line, you would have seen straight line, basically a train going on a track. Motion in a plane, vehicles going on roads. Vehicles going on roads, provided the road is completely smooth, is either forward, backward, left, right, but it cannot jump out of the road. Neither can it go into the road. Ships moving on the surface of water, they are all motion in two dimensions. But the minute you have an aircraft taking off, then that becomes motion in three dimensions, because aircraft in air can move forward, backward, left, right, up, down. That becomes motion in three dimensions. Similarly, submarine, that becomes motion in three dimensions. We are not doing that. We are doing only motion in a plane. So forward, backward, left, right, possible. Or forward, backward, up, down, possible. Or up, down, left, right, possible. Like this. Two axes. Any two axes. Now, when we do motion in a plane, Since it is moving along two axes, direction becomes very, very important. In straight line, direction was not important because just forward and the other is backward, very easy. But here, in motion in a plane, the body can move, for example, like this, like the green line that I drew. It can move along the white line that I'm drawing. It can move along the blue line that I'm drawing. It can move along the violet line that I'm drawing. It can move anywhere here, anywhere here. Now, how do I know which is the correct line? So in this kind of a system, we generally decide which line it is moving based on the angle that it makes either with the x-axis or with the y-axis. So the angle is 30 degrees with the x-axis, I know where it is. If the angle is 45 degrees with the x-axis, I know where it is. If the angle is 50 degrees with the x-axis, I know where it is. Even if the angle is 50.25 degrees with the x-axis, I know where it is. Any of these angles will give me the direction of that body with respect to x-axis, like this. So direction becomes very, very important. Hence, when we start this chapter, we first break the physical quantities into two. One is called scalars and the other is vectors. This is to understand the direction of the body. Scalars and vectors both are physical quantities, which we will learn in the next section. That's how we will start this chapter. We will start this chapter with first understanding scalars and vectors. Then we will apply it to the motion of a body. That's how this chapter is going to proceed.